Alright, so the next thing on the sequence of our videos is going to be on variance and standard deviation of a random variable. So if you recall what these represent, these are the measures of spread of our random variable, or basically our average deviation from our center, from our mean. So let's just take a look at an example really quick. Here we are going to look at the example of this random variable x, which represents the number of red lights a commuter would hit on their way to work. Where this random variable can take on anywhere from 0 to 5 lights. Let's just say they have to go through 5 traffic lights in order to get to work. So this commuter estimated that on average there's going to be a probability of 5% that they'll get all green lights and go all the way through. There's a 25% chance that they'll hit one of the red lights, 35% chance that they'll hit 2 red lights, 15% chance they'll hit 3, 15% chance they'll hit 4, and last a 5% chance that they're going to hit all 5 red lights. And so our goal first is we're going to first find out how many lights we expect to hit, which is basically our expected value in a way, each day. And then we're going to find the measure of spread, so the variance of x, and also the standard deviation of our value of x. And if you notice, in our variance and standard deviation, which is just square root of that, we rely on this expected value of x. So our first goal is to find out the expected value of x. So this is what we just went through earlier. So let's find this out. It's going to be expected value of x is equal to the sum of each value that x can take on, each xi, times its corresponding probability. So this is going to be 0.05 times 0. Or let's write it the other way around. 0 times 0.05. So we have the possible 0 times its probability, plus the next one, which is 1 times 0.25, plus 2 times its corresponding probability of 35%, or 0.35, plus 3 times 0.15, plus 4 times 0.15, and 5 times 0.05. And so let's multiply this out and actually find the sum so we can find the expected value. So this is going to be 0 plus 0.25 plus 0.70 plus 0.45 plus 0.60 plus 0.25. And we get an expected value. Let's see if I can add this together. So we got 1.3 plus 0.5 is 1.8 plus, that's 2.25. So the expected number of lights are, on average, if I were to drive to work a bunch of times and find the average number of lights I would hit, it would be 2.25. Now let's take a look at the formula for the variance. Again, we're going to be taking the sum of finding this for each value that xi could take on. So what are we going to do is we're going to find the sum of each value minus the expected value. So we're finding the deviation, or the difference, or how far we are from our expected value, 2.25. Square that to make it positive, and then we multiply by its corresponding probability. And that will calculate the variance. To find the standard deviation, since we have squared units here, we want to bring it back down to normal units. We just take the square root of the variance. So let's just go through that very quickly. The variance of x is going to be the sum of each xi minus the expected value. So let's find those. So it's going to be 0 minus 2.25. And then we're going to square it and times its corresponding probability, which is 0.05. Then plus the next term, which is 1. So we're going to take the 1 minus the mean, which is 2.25 squared. Right? We take each one squared times its probability of 0.25. Plus the next one, which is going to be 3, so we got plus the value of our xi is 3 this time, minus 2.25 squared times the probability of that, which is 0.15. And let's go on to the next line here. Plus the fourth one, which is a value of 4 minus 2.25 squared times its corresponding probability of 0.15. And last, we got plus 5, so that's 5 minus 2.25 squared times probability of 0.05. And if we just calculate this out,